Hello, ladies and gentlemen. Welcome to Chapter 7, Section 4. We're talking about function notation. Some vocab you need to know. Uh, Basically, the big thing we need to make sure we understand here is function notation is no different than normal equations. It just gives us a different way that they write it. So we treat functions as equations, and we can go from there. All right, so we see here uh, that they're giving us f of x is equal to 2x plus 4. That's the same thing as y equals 2x plus 4. Okay, now they're just saying this is an equation over here on the right. This is an equation. This is a function. So that means there's only one input. Um, there's only one output for every input that comes in. So they're asking us to evaluate the function for the values 2, 4, and 6. So how our work's going to look is we've got the function evaluated at 2. Okay, so this is never going to change over here on the left-hand side. And we place the 2 in for the x as well. So we've got f of 2, or the function evaluated at 2, is equal to, we have 2 times 2, which is 4. Add that to 4. So f of 2 is equal to 8. The same work would go if we were treating this as a normal y equals equation, except our final answer would just be y equals 8. So now it's just f of 2 equals 8. We follow the same process for 4. 2 parentheses 4 plus 4. So what we can do here is we can shorten up our work. Instead of writing f of 2 all the way down each time, we can just write it first and then just continue leaving this blank over here on the left hand side and end up writing our final answer at the end and giving ourselves our box there. And so in the last one we have f of 6 is equal to 2 times 6 plus 4, so that's equal to 12 plus 4, which is equal to 16. So that's f of 6 is equal to 16. So we have our three answers right here. Okay, so that's function notation and being able to write and evaluate functions. We treat it just like equations. We add, we put our numbers in for the x. What's on the left-hand side, or the f of x part, stays the same. The only thing that changes is what's on the right-hand side. Okay, so now what we also will have is we'll also have graphs. So they'll give us a graph that can look something like this. We'll get it drawn out here. Alright, so we've got lines connecting all these here. We've got 1, 2, 3, 4, and 5. These are the x values. 1, 2, 3, 4, and 5. These are the y values. Okay, so now what it's asking is it's asking what's the function evaluated at 1. So we're going to look at 1 on this x-axis. We're going to find it on our graph. So in this case, we've got the function evaluated at 1 is equal to 1. We then are asking to find the function evaluated at 2. So we find 2. We see this goes straight up. It's there. So that's at 3. So f of 2 is at 3. And then we've got f of 3. We're looking there. We find it on our graph. That's equal to 2. And then last but not least, we've got f of 4. And that's, we find it on the 4 there. That's about halfway between 1 and 2. So that's 1.5. Alright, so evaluating, looking at graphs, we just find the values on the x-axis and then find where they meet up with our graph. This example gives us nice neat dots for where to find it. You may not have those types of dots, but that's just the way it is. Okay, so that's where we're at. If you have any other questions, make sure you let me know, and have a good day.